Did you know a Muslim scholar invented algebra over 1,000 years ago? Imagine a world without equations, without the math that powers technology today. This incredible mind, al-Khwarizmi, didn't just write books. He built the foundation of modern mathematics. His discoveries traveled across continents, influencing Europe and shaping the very way we solve problems today. Yet, most of the world has never heard his name. He showed us that knowledge knows no boundaries, that one brilliant mind can change the course of history. Every time we use a formula, every time we calculate numbers, we are walking in the footsteps of a forgotten hero. This is more than history. It's a lesson in curiosity, dedication, and the power of human intellect. Remember, greatness is not about being known. It's about leaving a legacy that changes the world. Al-Khwarizmi, whose full name was Muhammad ibn Musa al-Khwarizmi, is often regarded as one of the most influential scholars in human history. He lived during the 9th century in the city of Baghdad, at a time when the Islamic world was experiencing a golden age of knowledge, learning, and scientific discovery. His work was not merely a contribution to a local scholarly community. It was the foundation upon which modern mathematics, particularly algebra, was built. Algebra itself, derived from the title of his famous book, Kitab al-Jabr wal-Muqabala, became the systematic method for solving linear and quadratic equations and introduced abstract reasoning that allowed mathematicians to generalize problem solving. Before al-Khwarizmi, mathematics was largely practical, concerned with measurement, trade, and simple arithmetic, and while advanced calculation methods existed, there was no organized framework to approach unknown quantities systematically. Through his writings, he created a methodology for manipulating equations, a set of rules that could be applied universally, and a conceptual framework that mathematicians could build upon. The beauty of his contribution lies not just in the mechanics of algebra, but in the idea that numbers and operations could be treated abstractly, independent of specific numerical values, opening the door to symbolic mathematics. His work was later translated into Latin in the 12th century, which allowed European scholars to access and develop these concepts further, directly influencing the European Renaissance and laying the groundwork for modern science, engineering, economics, and technology. Algebra, as introduced by al-Khwarizmi, is not merely a branch of mathematics. It is a way of thinking, a tool that trains the mind to approach problems logically and systematically. And it is foundational to the complex mathematical structures we use in physics, computer science, and finance today. Al-Khwarizmi's contributions are a testament to how knowledge transcends time and culture. By creating a methodical approach to solving equations, he gave humanity the tools to progress in countless domains. His influence extended far beyond Baghdad or the Islamic world. It reached Europe through translations and the spread of his ideas. During a time when Europe was largely in the Dark Ages, the Islamic world was a hub of intellectual activity, preserving Greek and Roman texts, innovating new ideas and expanding the boundaries of human understanding. Al-Khwarizmi's algebraic methods became a bridge for knowledge transfer between civilizations. They enabled European scholars to tackle mathematical problems that were previously unsolvable and allowed for innovations in astronomy, engineering, and navigation. For example, the ability to calculate and predict positions in the heavens relied on complex mathematical operations, and algebra provided the conceptual tools to model and solve these problems. In addition, commerce and trade, which were already expanding during medieval times, benefited greatly from systematic mathematical methods, enabling merchants and scholars to calculate interest, manage resources, and plan logistical operations with greater accuracy. Al-Khwarizmi's work, therefore, was not confined to theory. It had practical applications that influenced the world's economic, scientific, and technological development. Beyond the technical aspects, Khwarizmi exemplifies how knowledge is not bound by geography or religion, but can transcend cultures and generations. His life illustrates the importance of intellectual curiosity, persistence, and dedication. Living in the House of Wisdom in Baghdad, an institution devoted to the collection, translation, and expansion of knowledge, he had access to texts from various civilizations, including Indian numerals and Greek geometry. Rather than merely preserving these works, he synthesized, analyzed, and built upon them, creating original contributions that would impact generations to come. His ability to see patterns, abstract ideas, and systematic structures demonstrates a level of intellectual vision that remains awe-inspiring. It reminds us that progress in any field is often cumulative, relying on the insights of those who came before, but also that innovation requires daring to think differently. In this sense, Al-Khwarizmi's life is a lesson in the universality of knowledge and the way human intellect can transcend temporal and cultural boundaries to benefit all of humanity. Keynote 2, which focuses on the idea that knowledge transcends borders, and that Al-Khwarizmi's work impacted the entire world, is closely tied to the history of intellectual exchange. FO. The transmission of his ideas demonstrates how knowledge does not belong to one nation, religion, or culture. It is a shared human resource. When his works were translated into Latin during the 12th century by European scholars such as Adelard of Bath and Gerard of Cremona, these texts opened a gateway to a mathematical revolution in Europe. The very term algebra is derived from the Arabic word al-jabr, illustrating how linguistic and cultural exchange carried with it intellectual wealth. This transmission of knowledge also shows the interconnectedness of human civilization. While Baghdad was the hub of Islamic learning, the influence of Al-Khwarizmi's work spread through libraries, trade routes, and scholarly exchanges, eventually reaching distant lands where it would form the foundation for future innovations. The ripple effect of one scholar's work underscores the universal value of intellectual contribution. Ideas are not constrained by politics, borders, or geography, and when shared, they elevate all of humanity. The European Renaissance, fueled in part by access to these translated works, demonstrates the practical and transformative power of such knowledge exchange. Scholars in Europe could not have achieved advances in astronomy, navigation, architecture, or finance without the tools that al-Khwarizmi and his contemporaries developed. Algebra, therefore, serves as a prime example of how one idea, originating in a specific time and place, can ripple across centuries and continents, influencing societies far removed from its origin. It is a reminder that fostering and sharing knowledge is one of the most profound ways to impact the world. That education and discovery are universal forces that transcend divisions and unite human progress. Furthermore, al-Khwarizmi's influence illustrates the symbiotic relationship between cultures in the advancement of knowledge. The Islamic world absorbed and expanded upon Greek, Indian, and Persian knowledge, then created original contributions that would later influence European science. The journey of his works across languages and lands shows how knowledge grows cumulatively, with each culture adding layers of insight, interpretation, and application. His algebraic framework was not an isolated discovery, but part of a broader movement that emphasized inquiry, documentation, and dissemination of information. The universal nature of his work is further emphasized by the fact that the concepts he introduced are still taught worldwide, from classrooms in the United States to universities in Asia and Africa, illustrating the timelessness of his intellectual legacy. In essence, the ideas that al-Khwarizmi developed were never meant to be restricted to a single society. They were tools for human progress, applicable to anyone willing to study, understand, and apply them. Al-Khwarizmi's work also underscores the value of education. The way his ideas traveled from Baghdad to Spain, from Arabic to Latin, and from scholars to generations of students, demonstrates the enduring principle that knowledge is a bridge between societies. The systematic methods he introduced allowed for the universal application of mathematical reasoning. Algebra became a language that scholars across the world could use to solve problems, predict outcomes, and innovate solutions. In a sense, his life exemplifies the ideal that true scholarship is not about claiming ownership, but about contributing to the collective advancement of humanity. His work reminds us that investing in education, supporting intellectual inquiry, and fostering the sharing of knowledge are some of the most powerful ways to shape the future. This principle resonates today, especially in an interconnected world where ideas can travel instantly across continents, inspiring innovations in technology, science, and social development. Al-Khwarizmi's algebra is more than just equations on a page. It is a testament to the enduring power of human curiosity and the universal value of knowledge that transcends